Hello and good afternoon, CSI 158, Section 841 and 847 students at Anne Arundel Community College for the Cisco Networking Academy second 8-week course during the spring 2014 semester, Routing and Switching Essentials. Today's PacketTracer tutorial is going to cover PacketTracer Activity 8.2.2.7, which is configuring OSPF v2 in a single area. So let's jump right in. So our objectives are going to be to configure OSPF routing and then to verify our configurations. As you can see here, we have our common addressing table, and then we've got our background for the activity, as well as the different configuration steps that we need to do. So first off, it's asking us to configure OSPF v2 routing for router 1, router 2, and router 3. And it says use the following requirements to configure OSPF routing on these three routers. So let's drop this down so we can see the addressing table. So let's come to router 1 first. And let's remember that OSPF stands for Open Shortest Path First. And it's a dynamic routing protocol. And so let's go from user exec mode into privilege exec. And then we're going to go ahead and we're going to do a show IP protocols. And let's see if we have anything. So nothing's currently running. If I do show IP interface brief, we can check right here to see on router 1, are these interfaces properly configured? So gig 00 is 172.16.1.1, so that checks out. Serial 000 is 172.16.3.1, and then you have serial 001, which is 192.168.10.5. So all of our interfaces on router 1 are currently configured and they are correct. So let's jump in here to global config mode, and then we're going to go router OSPF, and if I do a question mark here, you can see that it's asking for the process ID. Now what's interesting to remember is the process ID for OSPF is locally significant, and what that means is we can have a different process ID on every router in the same area if we wanted to. And it'll simply depend on your use case and your environment as to whether or not that's something that you do. You can also keep all the process IDs the same. However, remember that they don't have to be the same. They can be different, and again, they are locally significant, and that is different than EIGRP, where the number that follows here when we're doing router EIGRP is the ASN, or the autonomous system number. And if I were to back up really quick, not to get too off course or off track here. So it's your autonomous system number with EIGRP. And again, it's the same value range, 1 to 65,535. And with EIGRP, when you want the routers to be, and they don't call it an area, but in the same autonomous system, then those routers do need to share the same number. And so that's one of the small differences between OSPF and EIGRP. And so we're going to use process ID number 10, and that's what we're being asked for. All right, so the router ID for each router, and again, this was actually an interesting conversation we had in class. Remember, the router ID, if the router ID is not manually specified as we're specifying it here, then what will happen is OSPF will look to see, are there any loopback interfaces? If you have loopback interfaces defined, then OSPF, again, if the router ID is not manually configured as we show it here, then OSPF is going to say, are there any loopback interfaces? And if so, which of the loopback interfaces has the highest numbered IP address? And the key to remember there is you'll see sometimes loopback 10 or loopback 99 or loopback 55. That's not the number that OSPF is looking at. OSPF is saying you've got 3 different loopback addresses. Of these loopback addresses, which one has the highest IP address? So if the router ID is not manually configured, like we're doing right here with router ID command, then OSPF says which loopback address has the highest IP address, and then that IP address becomes your router ID. And so if you don't manually configure it and you don't have any loopback interfaces specified, then what OSPF will do is OSPF will then simply select the highest IP address on any interface. And what that means is that can be an interface that is running OSPF, but it could also be an interface that's not running OSPF. And so a best practice is you want to make sure that you have predictability and that it's a deterministic value that you're using. And so therefore, the best practice is to specify it like we're doing here with the router ID command. That way you have control over it. So now it says a network address for each interface. And so we have 3 interfaces, and so let's go ahead with the network statement. And they've made this not too difficult for us, so we'll take the gig 00 interface first. And so let's do the question mark and see our options. So it wants a network number. So 172.16.1.0, and then the mask is going to follow. And so this is a wildcard mask, right? Whereas prior to this, we've been talking a lot about subnet masks. And so while we can leverage the subnet masks in order to determine the value of the wildcard mask, the value that follows the IP address here, this is going to be the wildcard mask. And so I'm going to break out the pen and go over here to the bamboo paper sheet in just a second. So we'll get the value in right away. So it's 0.0.0.255. And then unlike the RIP routing protocol, we do have some work to do here. We need to declare the area that this is going to be a part of. And so we're doing a single area, and so this is going to be area 0. And again, remembering that we need to have an area 0. And so interestingly enough, you can create an OSPF area that's not area 0. And so let's say we wanted to use area 51. We could certainly do that. However, we run into complications if for whatever reason we wanted to add additional areas to that area. And so it's always a best practice to definitely start your OSPF implementation out and your design and architecture with area 0 as your backbone area. All right, so there's the network statement for the 172.16.1.0 network. I'm going to hit enter, and as you look over here, we got 4 points for our, whoops, it just changed. So we had 4 points for the router ID, and now we got 8 points for the first network statement. All right, so the next network statement, let's take a look at this. So the IP address is 172.16.3.1. However, it looks like we're dealing with a /30, so a point-to-point interface. And so that's going to have a subnet mask of 255.255.255.252. So let's get our network identifier in here. So it's 172.16.3.0. And now the wildcard mask here is going to be a little different. It's going to be 0.0.0.3. And we're still going to put that guy in area 0. Right, and so we should see our completion percentage go from 12 to 20, well, 12 to 21. And so let's go ahead, now's a good time to take a look, and we'll talk a little bit about the wildcard masks. And so let's come over to the paper here. So we know what our subnet ID is, or I'm sorry, our subnet mask is 255.255.255.0, and that corresponds to a /24. Whoops. And so the way with OSPF that you calculate what your wildcard mask will be is you simply subtract the dotted decimal representation of your subnet mask from the all ones, right, or the 255.255.255.255, right? And so we get 0.0.0.255. And so this is our wildcard mask, right? And that's what we used for our first address. And so whenever you have a /24, this in OSPF is going to be your wildcard mask. So let's take a look at another example, which we just did a second ago. So let's put out the, we'll get the all ones. So the 255.255.255.255. And now we're taking a look at a /30. So a /30 is 255.255.255.252. And so again, very simple, 0.0.0.3. And that's the subnet, I'm sorry, that's the wildcard mask that we just used for the serial 000 interface network that we have now activated with the network statement under the router OSPF configuration. And so this would be a /30. So what would it look like if we had a /26? Right, so let's put /26 over here. So we would again 255, 255, 255.255, and so a /26 is going to be 255.255.255 dot, and remember we're borrowing 2 bits, right? So the value of the bits are 128 and 64, so it's 192, right? So if it was a /26 subnet, we would represent that with a wildcard mask of 0.0.0.63. And that would be our wildcard mask. And so again, I'll put this down here, wildcard mask. And so again, you simply subtract the dotted decimal representation of the subnet mask from 255.255.255.255. And that will result in the value for our wildcard mask. And again, this is OSPF. So we do a similar calculation, and we'll be talking about that next week when I post videos for access control lists. But there you run into some different challenges when you're calculating your access control list as opposed to what we're trying to do right here. And so again, let's try to keep this as sort of an OSPF only conversation right now as to how we determine that subnet mask here. Okay, so that is a real quick overview of the, I'm sorry, wildcard mask. If I said subnet mask, I apologize. Wildcard mask. Okay, so let's get down to that last statement on serial 001. So it's going to be network 192.168.10. And again, so if you see here, right, you can see that the serial 001 interface on router 1 is 192.168.10.4 is our network ID, and then the 2 addresses that go between 1 and 3 are .5 and .6. Our broadcast would be .7, and so we'll do .4, and then we already know that a 252, so a /30 is going to be 0.0.0.3, and we're also going to place this interface into area 0. And all right, we should see our total go up, and we do. We're up at 30 points now. Okay, so we've got our router ID, the network address for each of the interfaces, and then finally, and this is a very common thing to do and a great best practice, is we're actually advertising OSPF, right, or this network that resides here behind R1 for our LAN, which is 172.16.1.0. And that was the first network statement that we entered in here under the OSPF router config prompt. And so what we want to do now is, since we don't have anybody out here that's speaking OSPF, or that's going to be interested or trying to establish an adjacency or interested in receiving updates, we want to make this interface passive, right? And so what we want to say is the network statement is still going to be valid. And so this network will be shared with the other neighbors who are in area 0 so that they will know, if I need to know how to get to 172.16.1.0, I'm going to know how to do that if I'm router 2 or router 3. However, on this interface, no updates will be pushed out this interface because there are no routers out on this interface or a multi-layer switch that's running OSPF. And so while we turn the process off on the interface, that network that's associated with that interface is still advertised to our other neighbors who are in the same area. And so let's go ahead and do that passive interface command. So I want to get over to the gig 00 interface, gig 00, and we're going to do the question mark, and we'll take a look here. And so we've got a whole slew of commands that we can choose from, and we want to go ahead and do the passive interface command. And so let me make sure I've got that right. Yeah, it says do not use the default keyword. And using the default keyword would push multiple interfaces into passive. So the LAN interface is going to be set to passive. So in order to do that, we're going to go ahead and execute the command. Going to be IP, and then if I do a question mark, you'll see that OSPF shows up. OSPF, and then we've got interface passive. Or I apologize. So IP OSPF, and then passive interface is the command. And I don't see it listed here. Let me take a quick look. It doesn't want us to use the default. All right, so here's what we're going to take a look at. All right, so under the interface, and I think I may have confused myself, let's get back to the router OSPF 10, and we're going to do the passive interface from here. And so you can actually set it on the interface itself, but not in this instance. So we're going to go ahead and do passive interface, and it's going to be gigabit Ethernet 0/0, right? And again, this is under the router OSPF configuration. Our score should increment a little bit. I think it did there to 34. Okay, so for router 1, it looks like we're done. So let me go ahead and, let me type end, and then let's always save our configuration. And I'm going to close up shop here on router 1. And now we'll pull router 2 up, which is going to have a very similar configuration to router 1. And again, I'm going to go from user exec into privilege exec, and then into global config mode. So we'll type router OSPF 10, and remember, I could make this 1,000, and it's still going to work in the same area with router 1. That router OSPF process ID number, which is what that is, that OSPF process ID is locally significant, so it's only meaningful on this router. Okay, so router OSPF, and we're going to do process ID 10. I'm going to set my router ID again. And while I'm setting this, remember that if you don't manually configure the router ID, that OSPF will automatically look for the highest IP address on any loopback interface. And if there are no loopback interfaces configured, OSPF will simply pick the highest IP address of any interface. And it could be an interface that is running OSPF or that is not running OSPF. And so that's sort of the three-step process. All right, so we're going to put a network address for each interface. So we're going to do network, and we're on router 2, so it's 172.16.2.0, and the wildcard mask for a /24 is 0.0.0.255, and we're going to put him in area 0. And so then we're going to do another network statement, and this is going to be for the 172.16.3, and it says .2 right there, but if I slide down a little bit, you can see it's the network is actually 3.0, and it's a /30. That's the interface that goes to router 1. So 3.0, and for a /30, it's 0.0.0.3. And this guy is also going to be in area 0. And then finally, we're going to do, and there we go. We've got some activity with OSPF. So we've received a message here. It's OSPF adjacency change, process 10. So neighbor 1.1.1.1 on serial 000 went from the loading state to full, which means loading is done. So we are now at the full state with OSPF, and my command got cut off there. So we're going to go ahead and wrap up here with our final network statement. So this is going to be 192.168.10.8, and this guy is also a /30. So it's going to be 0.0.0.3, and we will also put that interface into area 0. So now we've set our process ID for router 2. We've got our router ID configured. The network address for each interface has been set up. And again, we want to go ahead and do our passive interface. And it's going to be the LAN interface. And again, here it's going to be gigabit Ethernet 0/0. And that should take us from 64 points up to 67. All right, so I'll type end here. And now, interestingly enough, if I do a show IP route, we now have some information in our routing table, and let's take a look. So OSPF is, we're learning about the 172.16.1.0 network, which if you remember, there it is right here. So we did the passive interface command on that interface, which is gig00 on router 1. But remember, I said that all that does is it makes it so that OSPF is not trying to send hello messages out this interface or multicast messages to establish adjacencies, because we know there's not going to be anyone over here to establish that kind of a relationship. However, that interface, or this network I should say, 172.16.1.0, this network is being advertised. And so here we see it. Router 2 has learned it. The O in the far left means it's OSPF. That's how I've learned this route if I'm router 2. This is the network I've learned. The 110, that is the default administrative distance for OSPF. 65 is the cost, and that's the metric that OSPF uses to determine what the best path is, or the shortest path to choose, and it's always the lowest metric will be preferred. So to go from router 2 to router 1 over this link right here, the cost is 65. And it says via, and so it's been learned via 172.16.3.1, and that was learned from, or to, you know, to get there, it's going to be across that IP address right there. And then I'm picking that up off my serial 000 interface, and that's how long I've known about that route. All right, so if I were to run that command again, that 107 is now 257. So it continues to increment. You can also see that we're learning about the 192.168.10.4, right? And we're learning about that network with an administrative distance as well as it's 110. However, if you look here, the cost is 128. So it's, to get to this network, the cost is more than to get to this network, right? Okay, so let's continue on here. So let's do a write mem and save our config. Close this window down, and now let's go ahead and wrap up with router number 3. And so we should have this down now. So user exec to privilege exec in the global config, router OSPF 10, and our process ID is 10, router ID 3.3.3.3, and we're going to go ahead and do network, and the 3 networks on router 1 are 192.168.1.0, and that's a 255 at the very end, /24, area 0. We're going to do network 192.168.10, and our IP is 6, but it's the network ID, or I'm sorry, we'll do the network, the /30 that we can see right here above where we're at. So 192.168.10.8, and the wildcard mask will be 0.0.0.3. That will also be in area 0. And now here, once I run this, you can see that we should also receive a message because router 3 should now establish an adjacency with router 2. So we should see a similar message letting us know that there's some activity here via OSPF. We'll see if it picks up anything, and then we'll do our final entry, and there we go, right? So the serial 001 interface, which is on the 192.168.10.8 network, now has an adjacency with router 2, and you can see here neighbor NBR, right? My neighbor is 2.2.2.2, and this is where it becomes really important because that's where the router ID can really help you in understanding your topology, is if you use a nice scheme to set up your router IDs, make it so that it's a valuable notation so that it can be used for more than just some random number, right? So I know that, hey, that's router 2. Okay, so now let's go ahead and add in our last network statement, which is going to be for 192.168.10.4, and again, that's a /30, and this is going to be area 0, and now we should also see an adjacency here. That's going to be, it'll say neighbor 1.1.1.1, and it'll be out serial 000, and sure enough, there we go. And so our adjacency has been established. It's gone from loading to done, and we're at 97 out of 100. Our final command, whoops, is passive interface, and this is our LAN interface. So let me slide this over. So this interface right here, right, we're going to make sure that the router is not sending hello packets or any OSPF information out that interface onto the 192.168.1 network because we know we don't have a router out there with whom he can establish an adjacency. So gigabit Ethernet 0/0, and that should take us to 100 out of 100, and so I'll type in. And so if I do a show IP route right now, you can see that router 3 is learning about 172.16.1 and .2 and .3, right? So it's learning about this network and this network and this network via OSPF, right? And it'll also show you which interfaces it's seeing, or that's how it gets to these different networks, right? This is how long it's known about it. And here are the interfaces out which traffic destined to those interfaces would go in order to reach those interfaces. So some other commands, if I do show IP OSPF and a question mark, you can see that we've got all kinds of information that we can take a look at. So let's see what interface shows us, right? So here it shows us the interfaces that are actually running OSPF, right, or that are participating in OSPF. Shows you what area the interface belongs to, the process ID, the router ID that's associated with it, and most importantly, and something to pay very close attention to, is the network type. And so our network type here is a broadcast network, so it's an Ethernet network. On our serial interfaces, our network type is point-to-point. Also important to note, the cost. I can see what the cost of that link is for me to go from the router out to this network. It's a cost of 1, because by default OSPF uses the reference bandwidth value for 100 meg, right? And so any interface faster than 100 meg, so a gigabit per second link, a 10 gigabit per second, a 40 gigabit per second, or a 100 gigabit per second link, those costs will all be 1 unless you change the auto cost reference bandwidth. Okay, and so then down here we have a cost on the point-to-point serial interface of 64. And so now this is interesting. So the cost across the point-to-point interface, let me make sure I've got the right one here. So 1010. So it's looking at this link right here, right? So the cost to come across this link is 64. The cost to come out this interface here onto this link is 1. So if I pull router 2 up and I now do a show IP OSPF, I'm sorry, show IP route, if I'm looking for that 192.168.1 network, and here it is, right, and I'll highlight the entire thing, what we're really interested in is, take a look. So router 2 is learning about this network, right, how to get there from OSPF, and that's what the O stands for. This is the network I'm learning about. Here's the default administrative distance for OSPF is 110, and there is our cost. So from router 2's perspective, for me to get to this network 192.168.1.0 that sits behind router 3, my cost is 65. If you come look over here, I would first have to come across this serial link, this point-to-point link with the cost of 64, and then finally a cost of 1 to go out the router onto that broadcast network interface. So that's how it comes up with a cost of 65, right? Okay, so our last step, and I believe it's going to ask to configure each router roundtable, show the route and topology, correct? We're going to verify our connectivity. So PC3, we're going to pull PC3 up, and let's go ahead and confirm that I can ping PC1 and PC2. So 172.16, whoops, 172.16.1.2. Is that correct? All right. And just because we're running OSPF doesn't mean that we skip the process of ARPing out if we need to find our default gateway and to make our way over there. Now, taking it a step further, right? There's a command called traceroute or traceRT, and let's see if it's going to take 72.16.1.2, and if you remember this, yeah, traceRT. So if you remember this from the 157 class or the networking foundations class, or the introduction to networks class. The traceroute command shows me the path that I take when I go from one location to another location. So PC3, my first hop is my default gateway, which is this interface right here. And that's what this first line shows you, right? So it shows me that the first hop the packet takes is to the default gateway, which is 192.168.1.1. It then shows me that the next hop is over to 192.168.10.5, which is this interface. And then the final hop is over to the PC. Now, if you notice, I have multiple ways to get over to PC1. So the shortest path, right, and that's the key. So let's pull this up. This is router 3, and if I do a show IP route, what does it say here? So for me to get over to the 172.16.1 network, the cost is 65, and that's my best cost, and that's going to happen out my serial 000 interface, and it's going to be via that next hop IP, which shows up right here. So I can trace my route that my packet is going to take by using that command. And so here's what's interesting. So to show or to prove that this is the value of a dynamic routing protocol. So I'm going to go ahead and I'm going to go on router 3. Let's go into global config mode and let's jump into interface serial, and let me make sure I get the right one here, 10.5, 10.6. So serial 000, right? So if I do a do show IP route, you can see, again, my shortest path to the 172.16.1.0 network is going to be via serial 000 with a cost of 65. But what happens if that interface that I want to hop out, that's the shortest path, and let me slide this guy over here and watch what happens. What happens if that interface gets shut down? So a couple things. The first is we get a adjacency change notification, which we would want to send to a syslog server, for our neighbor. And it says on serial 000 went from full to down. So right now my neighbor's down, or it's detached. But we know that it's down. We just shut it down. So what's interesting is I still want to go over to that 172.16.1.0 network over here to PC1 behind router 1. So now if I do a do show IP route, does OSPF auto-magically recalculate, run the SPF calculation, and then insert another path for me to get over to that network? And it does, right here. So again, I'm still learning about this network via OSPF. My administrative distance is 110. However, my cost, as you can see, is 129. And now I'm going via another interface, which is the 10.9 interface, right? So now the packet, instead of coming straight across here and using the link between R3 and R1, is going to have to come to R3, then to R2, and then down to R1 and out. And so let's double check that. So from PC3, if I run that traceroute command again, you see now that I have 4 hops I have to maneuver across. My first is my default gateway, but then just like the show IP route command is indicating, take a look at that next hop, 192.168.10.9, and that's this interface right here on router 2. And then it drops down to the 172.16.3.1, which is the interface right here on router 1. And then finally, you've got the 172.16.1.2, which is our final destination, and that is our PC1 interface. And now this will be true for all of the PCs. If I pull up PC1, and let's do a trace route over to PC3. Let me move this down a little bit. So if I do a trace RT over to 192.168.1.2, you're going to see here that we also have 4 hops. And again, the path that we're taking, since this is down, this link is down here, we're going to have to come out to router 1, up to router 2, down to router 3, and then over here to PC3. And so the key takeaway here is that this is really the value add of dynamic routing protocols. We have a link failure that goes down. OSPF will run the shortest path first algorithm, quickly recalculate a new path out to that network if it has one, and then immediately adjust the routing table to reflect that, hey, there's a new route. And so now this raises the question, what if I do a no shut? Is OSPF smart enough to remove this higher cost route, because we're going across multiple serial links here, and that's raising the cost of our route, and I'm going to bring that interface up. And so let's see what it does. So the stage changed to up, and now we want to wait a few seconds because the OSPF adjacency should reestablish, and we should see from router 3's perspective, there it is right there, that I'm learning from neighbor 1.1.1.1, right? So our final check, let me go ahead and type end here. Our final check will be, let me do a show IP route, and does OSPF know, hey, I've got this new interface that's up, it's got a better cost, which is 65, or I should say a new path has come up, and the cost overall will be 65. Is that better? And am I going to supersede the entry that's in there to make sure the shortest path first is followed? And as you can see, that took place. So OSPF reinserted the better route back into the routing table. And so now, one last check here. We'll do a quick trace route again over to 3. And so there you go. It's back out that original path. It's no longer going the opposite direction. And so again, this is really the power and the beauty of the dynamic routing protocols such as OSPF and EIGRP, where it's really almost self-healing as long as they've got additional paths to get to your network. All right, so this has been PacketTracer tutorial 8.2.2.7. I hope you enjoyed this video, and best of luck in your studies.